Hey guys, today we're going to work on an introduction to imaginary numbers. So for a lot of you, this will probably be review because this is a topic that's typically covered in Algebra 2. But for those of you that didn't understand it then, hopefully this revisit will help. So let's start with what an imaginary number is. An imaginary number is a number that's incomputable. And we use imaginary numbers for the purpose of technology. Computers and complicated technology need imaginary numbers for their coding processes. So we're not going to go real in depth with imaginary numbers, just kind of cover the basics. But I want you to know what they are. So an imaginary number we're going to call I. And that is going to be equivalent to the square root of -1. And that's because it's impossible to simplify the square root of -1. In fact, there are no answers to square roots of any negative numbers. So because it's incomputable, we call it an imaginary number. Now I have two definitions here on the screen. I have that I is equal to the square root of -1. That one is super, super important. But I also have this one over here that I squared equals -1. This I squared equals -1 is not magic. You could simply find this value by taking your I equals the radical -1 and squaring both sides, and you would end up with I squared equals, and then the square root and the squared would cancel each other, and that's where the -1 comes from. Okay, so it's not coming out of thin air. But these two things are things you're going to need to memorize for sure. So some simple examples first. Basically, we want you to start every problem by asking yourself, is this an imaginary number? And if you see a negative inside of a square root, then the answer to that is yes, it's an imaginary number. Now to simplify it, what you're going to do is you're going to pull the imaginary number, which is the -1 component of that radical. You're going to pull that and separate it from the numerical value itself, which is 5 in this case. And then you're going to put each of those things in their own radicals and simplify. When I say simplify, what I mean is recognize that the square root of -1 is I, our imaginary number. And then radical 5 cannot be simplified, so we would just bring that over. And so I radical 5 would be your simplified answer. Let's try that again. So B, is this an imaginary number? Yes, because I see a negative inside of a square root, and that's not something that we can compute without imaginary numbers. So we're going to start by separating the imaginary number from the numerical value itself. And each of those items can then go into their own square roots and simplify. So I know that the first radical with -1 inside is I. That's the definition of an imaginary number. And this time I can actually simplify the square root of 25. That is just 5. Now, for me, I don't like the way I5 looks, so I would probably flip it and put 5I as the final answer for that. Okay, this last question on this slide is the same stuff again. So we're going to start out by separating that negative radical -1 and the 50, because the radical -1 is the imaginary part of this question. And then we're going to put each of those into their own radical, and we're going to simplify. So again, the square root of -1 is I. This time, 50 is possible. It can be simplified, not like 25. It's not going to be just a whole number. But you can do a factor tree for 50 and figure out what that would be as a reduced radical. So this is what we did at the beginning of Unit 2. So this would end up being 5 radical 2. And then we're just going to do a little rearranging to make this look better. So this would actually look a lot better, I think, if we put 5I and then put the radical 2 at the end. Okay, so second type of example is simplifying again. but we're being asked to add or subtract. And in order to add or subtract something with radicals or even imaginary numbers, they have to be like terms. So these two terms in example A are not like terms. However, if you recognize this negative inside the radical, you know that these are actually imaginary numbers. So why don't we try to rewrite them as imaginary numbers, and then we can go see if we can solve it. So we've got our imaginary part separated from the real part for each of these. And then we're going to reduce down. So the square root of -1 is I, and the square root of 16 is 4. So 4I is what that would be as an imaginary number. And then for the second radical, we have an I, and then 49 square root is 7, so 7I. Now, when you look again, these are now like terms because they both have an I. So you would subtract the coefficients. So your answer is -3I for that question. The second example, this one's already been turned into an imaginary number for you. So you just need to decide if they are like terms. In order to be like terms, you have to have the same variable, which they both have an I, and you have to have the same radical as well, and they both have a radical too. So that means that these are like terms, and if they are like terms, you will just take the coefficients, the 1 and the 3, and you'll add those together and bring over the variable and the radical. So this would be 4I radical 2. Okay, multiplication. So kind of similar to what we just did, except you can multiply and divide anything you want. They don't have to be like terms to multiply them. What they do have to be, however, is simplified. So we have to simplify these radicals down because they are actually imaginary numbers due to the negatives that we see here inside the radical. So we have to simplify each of these radicals before we can multiply them together. Okay, now hopefully at this point you're seeing a couple of ways that you could maybe make, shortcuts for simplifying imaginary numbers. And if you see any shortcuts, great, use them. If not, stick with me and show your work like I'm showing. So for square root of -4, that would be I times 2, so 2I. And then square root of -25, that one's going to be 5I. When we multiply these together now, we're going to multiply the 2 and the 5 to get 10. And then I times I would be I squared. New thing, I squared can be reduced because I squared is equal to -1. So you're going to get, when you get 10I squared, you're going to plug in -1 in place of I squared because that's what I squared is equal to. So this will turn into 10 times -1, which is equal to -10. So that is your final answer. B is already turned into imaginary numbers, so we're going to go straight ahead to the multiplying step. So we start with I times I, which is I squared, and then we multiply the radicals. So radical 2 times radical 3 would be radical 6. Same thing as last time, I squared is equal to -1. So I'm going to plug -1 in place of I squared. And then I'm just going to simplify. I think I'm just going to make it negative radical 6. All right, last thing. We have certain cases where we've got imaginary numbers in a fraction. And if you recall from the previous lessons in Unit 2, there was a rule or formality, I guess, where you were not supposed to leave a radical in the denominator. And so we would do something called rationalizing, that's what I'm doing right now, to make that radical get out of the denominator, to move it out. So that is a similar process to what we're going to do now, okay? Here's why. I Remember that I is equal to the square root of -1. If you have an imaginary number down in the denominator, that's like having a radical in the denominator. That's just like what I just did up here, okay? I can't leave it there because it's like not proper form. So we're going to get that out of the denominator in a similar process. It's still called rationalizing, by the way. So you can make this easy or you can make this difficult. The easy way would be just to multiply the top and the bottom by what you want to get rid of. I need the I to not be there on the bottom. So I would just multiply the top and the bottom by I. Or you could multiply by 3i. It won't matter. Pick whatever you feel like doing, but I feel like I'm going to go with the simplest of the two just because that's less work. So I'm going to multiply the top and the bottom by I, and then I'm just going to simplify in steps. So the top would be 2i, and the bottom would be 3i squared. And then we're going to remember that, oh yeah, I squared is -1. So let's make that change. And then we have successfully removed the radical or the imaginary number out of the denominator. I am going to do one extra little step that's not completely necessary, but I think it makes it look nicer if you move the negative to the front. Okay, let's look at another one. B is the same thing. It's just not in the exact format that we're used to. It's still in radical form where this basically signifies that this is an imaginary number. So I'm going to start by writing it as an imaginary number. It would end up being I radical 2. And then I'm going to proceed with moving the radicals out of the denominator. So in this question, I is a radical, and so is this 2 here. So I need to multiply by I radical 2 on the top and the bottom because I need to get rid of both of those things. Okay, the top is going to just be 6i radical 2 if you multiply that stuff together. The bottom will be I squared radical 4. And we're going to focus down here on simplifying. So let's leave the top alone for now. And let's go to the bottom. I squared is -1. Square root of 4 is 2. And then that means the denominator is -2. Okay? We can do a couple other simplifying steps. I guess just one other simplifying step. And that is that these coefficients on the outside are divisible. So I can do 6 divided by -2 and get -3i radical 2. So that would be your fully simplified answer. Okay, one more question. And this one at first glance looks like it's totally unrelated to imaginary numbers. But bear with me, I want to show you what happens here. So if I'm just going to go through and solve this equation, we're going to subtract 19. We're going to get 2x squared equals -16. Divide by 2. Right? Everything looks fine so far. And then we get to this step. And in order to undo the squared, we would have to square root both sides. And that's going to create an imaginary number. Now, right now, it doesn't look like an imaginary number, but we know that if there's a negative inside the radical, that it's an imaginary. So we're going to simplify this, and we're going to write it in imaginary number form, just like we've been working on in this lesson. So I need to simplify and do the square root of -1 is I. And then 8 is something you can break down and simplify as a radical. So that would be 2 radical 2. And then I'm going to rearrange and call it 2i radical 2. And that is it. So you have a Delta Math assignment over this lesson, and I think it's a pretty simple one. So please let me know if there's anything that you need help with.